Okay. Okay. Taxiways by Roundout, normal Sudoku rules apply, so digits 1 to 9 in every row, every column, and every 3x3 box. The rules visible? Yeah, they are. Along thermometers, digits must increase from the bottom to the tip, so there must be an increase here. Arrows, the numbers along an arrow must sum to the number in the respective circle. So these digits sum to this, these digits sum to this, and so on and so forth. Yeah, okay, that's it. With that, we can actually start solving the puzzle now. So let's restart this one, right? Okay, so this 5 is very suspicious. Wait, hold on. 5, 6, 7. This is forced, right? Because these must all be greater than 5, and the only digits greater than 5 are 6, 7, 8, 9, which have to be placed in order here. So that's forced. That's 4 forced digits. Which is very suspicious because I'm a little scared of this one now. Those can't be 8. This can't be 8 by this, and this can't be 8 either, because these sum to 6. Well, in fact, because they sum to 6 and cannot repeat, they're in the same column, they must be just 1, 2, and 3. So 8 in this box has to be there. 8 is in one of those cells. This is greater than 5, which is, well, I mean it's 6, 7, 8, or 9. This one, well, this can be 3. Okay, these digits are again at least 1, 2, and 3, so this is at least 6, but can't be 6 or 8, so it's 7 or 9. And these digits sum to 8. Well, if they sum to 8, they must include a 1, because if not, they will be 2, 3, and 4, which is a 9 at minimum. Right. Seven, 8, 9. Is this also 7 or 9? These sum to 8. This one, well, this is 10, 10 is 13, so this, oh, wait a minute. Yeah, okay, wait. Yeah, okay, I see. These digits, I think in particular, are interesting because this is minimally a 10, because there are 4 different digits in the column. These is minimally, these are minimally 1 and 1, which is therefore a 2 at minimum. So at the very least, these sum to 12, right? Yeah, I'm comfortable saying that. But the thing is that these two cells also sum to a 12 a minimum. So this is, again, at least a 6. It can't be 6, 8, or 9, and therefore just must be a 7, I think. Yeah, because these sum to at least 12. So even though this could theoretically even be a 4 if you had like a 1, 2, 1, it can't be because that would break the 6 arrow along with it. So these in fact sum to 13. What does that mean? Well, I mean it could mean anything. This could be the traditional 1, 2, 4 triple, but it could also be 5, 1, and 1, I think. So that's okay. And then these guys, well, maybe I could look at these now. Yeah, these cells, because they must sum to 15, and this is minimally a 10. So this is at least a 5, or at most a 5. Sorry, at most a 5. But at most a 5 doesn't say much because it could still be a 1. It could still be a 2, 3. It doesn't even have to have a 1 on it. But that really does seem sort of interesting. Right. Maybe it's all of these actually. Maybe it's all of them together. Because now this might actually interact with this interestingly enough. Because this is now at least 15. I mean, this could be a 3 though. If this is 7, it could be like... Oh, but this 3 is here. Very interesting then. Does this have to be a 1? 5? No, it doesn't have to be, does it? I don't think so. Oh, you know what? You know what though? These two cells see every single one of the blue cells, ignoring this. This cell sees all of these. So the question is, what could be there? Or what could you remove from this? I'm pretty sure 1 cannot exist on these two cells. And neither can 2. I mean, I could do the math and say something about that. If this was that's just really tough to decipher though. If 1 wasn't here, then minimally this is... Well, minimally this is a lot. Right? If 1 was here, then this is like at least a 14 already. This is at least a 5, making this a total of at least 19. If this is a 2, then minimally this is 1, 3, 4, 5. And can I do any math with that? 1, 3, 4, 5. 1 plus 3 plus 4 plus 5 is 13. Plus 1, 3 here, which is another 4, is 17, which doesn't work. So this is at least 17 if 2 is on here. If 3 is on here, then this is at least 1, 2, 4, 5. 1 plus 2 plus 4 plus 5, which is 12. Oh, but now if you add 1, 2 here, that makes up exactly 15, which is possible. So it is possible to have 3 on this set here. And therefore, I guess it's also possible to have 4, 5, and 6. So that wasn't exactly helpful, but I can tell you that 1 and 2 cannot be in here. Alright, fair enough. What about this again? Maybe look at that again. Could this 8 have a... This is I don't know. I don't actually see anything about this. This one is deceptively simple looking. But I'm pretty sure it has some like huge arrow mishmash concoction added to it. Because like this deduction was probably already really hard to spot. I think, I don't know. I'm not very good at solving anyway. I wouldn't think this 8 matters much, does it? I wouldn't think so. Actually, yeah, could we figure out what these digits are? We know that this is either 511 or 124. If it's 511, it's 511 like this, right? Oh, that fails. Wait, does it? No, it doesn't. No, it does not fail. Unless it does. It doesn't fail, I don't think. Because could this have no 1 on it? And I think the answer is yes. Even without this 3, this is at least 2 and 4. And then with a 2 here, makes it exactly 8. So, well, at first glance, it looks possible to have a 511. Well, the other way is 124. And because this can't be 1 and 2, the 1 and 2 have to be outside. The 4 has to be inside, then makes that a 4. And then these would both be 1 or 2. Alright, well I guess those are our options now. There we go. What are the possible values for row 4, column 2? Oh! Well, I guess I figured that out somewhat. Well, this does make a pair, I guess. That's probably significant. What? What would that look at? That looks at this. It looks at that. These are either both 1 or 1 and 2 pair. What does that do? Five, 1, 1, 4, 1, 2. Makes those are the same, which forces it. Those are the same, forcing it onto this arrow somewhat. If it's 1, 1 over here, then it's just 2, which doesn't do anything. Actually, 1, 1 here makes it very constrained, so then be a 2, like, and then it's be 2, 4. But a 4, 1, 2 actually makes it maybe less constrained. A 4 here removes that from being a 4. This can't be 4 either actually, because then this would be 1, 3 by force. So a 4 here removes a 4 from this cell. Could it be like a 5, 1, 2? Yeah, there's a lot of options for this. It could also be like 1, 2 and then a 5 here, I guess. Those two are the same, which means one of those are here. Means it's either well, okay, wait, hold on. This can't be 1, 2. So, even with this 3 here, this must have at least a 4 in it, right? Because this can't be 1, 2, because this is either 1 or 2. So you can't have this be a 1, 2 pair. Minimally, this must have a 4 on it. This has a digit here that's either 4 or more. Okay. Well, what's the maximum you can have this be? It's a 4 or 5. Whatever that higher digit is on this here is 4 or 5. It can't be 6 because then you'd have 2 1s here which break this. These can't be both 2s. So it's whatever is here is either 4 or 5. Does that say anything? The 5 would then be here. This would be then a 1, 2 pair. That's the only way we can make 3. Oh, wait. That, whatever this would be the other one. So this is like a quote-unquote 4, 5 pair. 6 is here. And then 3. Well, 3 is here as well. Oh. Okay, I see. So, repeating that logic again, there must be a digit here that is at least 4 or higher. But that 4 or higher digit cannot be 6 or higher. Otherwise, you'd break this arrow. Therefore, whatever digit is higher than 3 here must be 4 or 5, which is the complement of this one, which is also 4 or 5. And therefore, what I'm saying is that 6 in here must be one of those cells. And also, 3 must be in one of those cells. That's a 3, 6 pair. Okay, I think this is just very confusing. I should not put those there. But again, these are 1, 2, 4, or 5. Like, as per normal. And then, well, is there anything else obvious that I'm also missing? Okay, well, I can tell you that what those cells add up to, maybe. Because by the 45 thing, I guess, these are 15. these are 18, that's total of 33. So these sum to 45 minus that, these sum to 12. Oh, these sum to 12, and we know all of these sum to sorry, I could have just done 1 plus 2 plus 4 plus 5. Whoopsies, 1 plus 2 plus 4 plus 5 is 12. And because these sum to 15, we therefore know that these sum to 3, which therefore make this a 1-2 pair. Okay, that was way easier than I made it. So this is 4 and 5. Alright. Oh, there's some more logic with this, I'm pretty sure, that forces it even further. Because I'm pretty sure it's not just 1, 2, 4, and 5 on here. There's something else. There is something else. Like 4, 1, and 2, right? Actually, that's not true. If this is a 4, then this is a 5, and this is just 1, 2. Which I think the order right now we don't know, and we can't figure out. If this is a 5, then this is 1, 1, and then this is a 2, 4 pair, making this a 2, 2, 4. So is this never a 1? I think that's never a 1. Yeah, I think this is never a 1 in both cases that we saw. If this was a 1, then this is not 1, that's 2. Then this is 4, and this is 5. And then, yeah, then you'd have 2 and 5 in the same arrow already. Okay, so this is not 1. Small deduction, but that works, that's fine. Okay. Well, I mean, that was really cool. I liked all the math that you had to do there. A lot more complicated than I would have thought it'd been. Maybe I look at this now. Does 1, 2, 4 work there? Then this would be a 5, but I think 5 is possible there. Although 1, 2, 4 here makes this a 2. Which would make this... Oh, I guess 5, 1, 2 works. Right? And you could have like a 4, 2, 1. Yeah. And what about a 9? A 9 could still be 2, 3, 4, I think. And then this would be basically identical. Although maybe there is something about this digit then. 9 can also be like 1, 2, 6 if I tried hard enough. Could be 1, 3, 5. Yeah, okay, I don't think there's much else we can do there. Or maybe there is, maybe there is. Oh, I see. This is either 1 or 2. It can't be 6 or higher. Right. This can't be 3, 4, 5. It can't be 7, 8. And it clearly can't be 9 either, but it can't be 6. Because the only way to make 6 work if you made these 1 and 2 to make this a 9. But 2 in this box already prevents that. So 6 doesn't appear in this cell, and therefore, because it can't be 3, 4, or 5, it's just 1 or 2. Which forms a pair. And then these are 6 and 9. Oh, which I can fix. That's 9. And then that is 6. Alright, okay. And then these are 3, 4, and 5. Yeah, that works. That's not 4. This 1, 2, 4, 5 is strangely not done yet. It's not a quadruple or anything. 7 and 9. Actually, if this was a 9, how would you make this work? Is this 2, 1, and 6 only? No, it could be 2, 3, 5. What am I saying? Could be a lot of things. Okay, I can say A is one of those cells because, well, no, what am I saying? A can be in all 3 of those cells. Okay. Actually, this 8 might be useful now, maybe. Maybe. These are greater than 4, but not 8 or 9. So these are from 5, 6, and 7. I guess I can just good lift it and see what happens after that. That should that should do. Oh, yeah, okay, this is all actually solved because of this box here. This 2 sees those cells, and none of these cells can be 2 because they're all bigger than, they should all be bigger than 5. So 2 is in one of those cells, which means that none of these are 2s. Alright, so that's 1, that's 2, that's 1, that is not 1 anymore. This is a 4-5 pair, meaning that is a 2. This could still be a 2. Yeah, okay, this is still somewhat stable. Where does 3 go in column 3? Oh, that is true, yeah. 3 can't be there, so 3 is just there. These are 4, 5, 7, 9. Okay, nothing much there. Sorry, I was thinking a little bit. What are we missing here? 2, right? Yeah, 2 in this column is just there. And this is 5, 6, or 7. And then I guess 2 is one of those cells. That doesn't really help. 2 is in one of those cells as well. One, 3, 4. Oh yeah, this can't be a 7 now because this is at least a 3, 4 pair. So yeah, because the 1 and 2 see both these cells. So this is not a 7, it's just a 9. So these add up to 8 and can't be 2, 6. So it has to be, can't be 1, 7 either. So it is 3, 5, which is resolvable. And then that resolves this. And then these are 4, 5, 7, which is cool. Yeah, sure. And you have 1 and 4 as well, which are not on the thermo. Thermo. I was gonna say 7 in this box is one of those cells. Does that help? Not really, no. It does somehow give you a 7 here, but that also doesn't help much. Alright, I'm gonna keep looking. I'm gonna stare at this. Actually, I feel like this 8 somehow gets important sometime soon. But maybe not, maybe it's just some stupid Sudoku that I have to do. 1 is in one of those cells, which again doesn't do much. 3 also actually, 3 is in one of those cells. But I can't do that with any other digit for some reason. 5 in column 8. This? Oh, it does. Wow, why did I not see that? Alright, thank you very much. This is therefore 2, that is 1. Okay. Oh, well, 1's in one of those cells, 1's in one of those cells. Yeah, same old. Five here? No, okay, I mean that's just 7, sorry, that is 5. I really should finish all my checking first before moving on to other stuff. Wow. Alright, that is a lot more digits. So that is very helpful. 1 and 4 in here. We don't have much info on anything else about the thermal. 8 is one of those cells. Four in this box has to be there. Which then, what does it do? 4 is one of those cells, right? Yeah, in fact, isn't this just a 1, 3, 4 triple somehow? Because in this column, yeah, 1 in this column can't be here, so 1 is one of those cells. And then 3, those ones put a 1 here. The 3s put a 3 here, and then this 4 can't be in those cells, so it's one of those cells, which means that 4 is here. So it's like 1, 3, 4, something funny like that. I mean, that's useful. How was that intended? I don't know. Is that 7, 9? That was pretty obscure looking, actually. The 1, 3, 4. Although I guess even without this 4, you could have figured that out. Alright. And then what do we have? This is 1 and 4. We have 1 and 4 in here so far, but nothing else. I don't remember. Yeah, okay. Two, 6, 7, 8. I don't know. That's like 6 or 8 or something like that. I'm just gonna mark that for now. Can I like sort of do this? This is oh yeah, 7 in this box. I should have just seen it's there. 7's there. This is 5, 6, 9. This is 1, 2, 1, 2, 3. Just 1, 2, 3. This is actually this 7 makes this a 6, so that's a 5. This is 7, 8, 9, and then that's not 8. And then 5 in this box is just here, so that fixes this. Yeah, it does. What else is there? These are 1, 2, 3, and 4. Oh yeah, and one of these are 1s, right? We figured that out because the 8 must have a 1 on it, and there is no 1 here. So this points at that, and is not 2, 4 either, so that's just 3. Meaning this is 1, 2, 4. This is not 1. I mean, that probably puts some pressure on this. This is like 3 or something. Is it forced? Yeah, I think it's a 3. It's definitely just a 3. How can I say this is it must have a 1 on it, and it's therefore either a 1, 4 or a 1, 2. If it's a 1, 4, that makes this a 3. If it's a 1, 2 though, then that sums to 3, and so this must be a 5, which isn't valid. So this is a 1, 4 definitely with a 3 here. So that's 2. Meaning that this is 1. Sure. And then this is 4. And then a lot of random stuff coming up. These are 6, 7, and 9. And then these are both not 6, so 6 goes there. This is a 7, 9 pair which sees that, so that's an 8. And then, well, I guess this is 1, 2, 3, or 4, but it can't be 1, 3, or 4, so it's just a 2 in this row, which should fix most of the low digits. Oh my god, another 3 in the corner. We keep seeing this everywhere. Was this intended, like the 3 specifically in the corner? Because I'm pretty sure every puzzle we've had until now has had 1 3 in the corner somewhere. That's so cool. That's a 6. That remove that fixes that. This 5 6 sees that, so that's 9. This is not 5, that's 6, so that's 5. That 9 sees a 7 here, that's a 9 there. This is, oh, I still don't know what that is. This is 1 2 3 4. This is 6 7 8. Sure. And then this is, well, I mean, it's a lot of things. What is it? This is 6 7 8 or 9. Alright, whatever. This can't be 8, can't be 6 either. And then that can't be 6, but can't be 9 either. Oh, so that makes it a 7 8 pair. So that's 9, that's 6, that's 8, that's 7, that's 8. Sure, I'll take that. This is therefore a 9, that's a 7. I mean, this, yeah, no, we wouldn't have seen that yet. This is 1 4 6. Yeah, this 1 6 over here makes that a 4. That is 1. I cannot type. That is 6. Jeez. Okay. And then, can I do anything else? I mean, yeah, this 7 9 pair is still really annoying, and I can't fix that yet. Just gotta do other stuff first. Yeah, like 2 here. This 2 sees that, so 2 goes there, and then these 7 see all but this, so that is 7, which finally fixes that. 9 goes in that box, cell. Jesus. This is 1, therefore this is 4 and 8, so that's 8, that's 4. Yeah, nice. Yay, okay. Oh, I thought my stream restarted. Did it restart? It doesn't look like it. But thank you. I did like this puzzle a lot. It felt like a lot of it was already fit in, because was it meant to introduce one simple trick, or not simple? What am I saying? Yeah, I really felt like it was that one trick that I was supposed to look at. It was really cool though. I really liked how all the arrows interacted with each other. Restarted right when you were eliminating the... Oh, I'm sorry. The 6 from roll. Oh man. Oh well. That's okay. You saw me finish the entire puzzle. Although actually, like, I've been recording this entire time. I hope you're fine with that. I'm gonna like edit this and make a very short video of my solve of this puzzle.